Today we discuss so many important spaces. Okay, some convergent sequence space, some sequence converges to zero, this sequence space, and obviously some sequence spaces whose finitely many term is that means finite or many term is represent and others term are zero. This is denoted by C00. We also discuss these spaces and obviously discuss these spaces are Banach space or not. Today we start about that, but in previous class we also discussed L infinity with respect to infinity norm be a Banach space and LP with respect to P norm is a Banach space. Okay, now we start from this. See those sequences in K where xn is convergent, and C0 here xn, those sequences in K such that xn converges to 0. Okay, and C00 here such that xn in K, okay, such that x equal to x1 x2 xn 0 okay. In this way these terms are represent, okay, some term x1 x2 xn and others are 0. Okay, this one is, that means this type of sequences are obviously here represent x, not x, here xn, then this one is better, or that means here we write y1, not here x1 is better, and here obviously xn. Okay, and this xn and this xn are different. Okay, this one element of xn and this one obviously sequence term. Okay, so represent if here x1 then x1 0 0 0, here x2 then x1 x2 0 0 0, here x3 then x1 x2 x3 0 0 0, and in this way. Okay, so this one are the spaces C0 and C00. Okay, now we discuss about that portion. Obviously one important topics where the space C0 of all sequences in K, converges to 0, okay, with norm x equal to supremum of K belongs to n mod of xk, where x belongs to C0 is a Banach space. Okay, we have to show that is a Banach space. So today we also prove that means some spaces C0 obviously of all sequences in K converges to 0 with norm x equal to supremum of K belongs to n mod of xk, x belongs to C0. Okay, that means where this x converges to 0 must is a Banach space. We have to prove that. Now start from that. Here we write about that. We know that C0 norm infinity be a norm space, C0 norm infinity be a norm space. Okay, then we have to show that, we have to show that C0 norm infinity is complete. Okay, now we start from that. Yeah, right, this one. For this let, okay, let x in va Cauchy sequence in C0. Va Cauchy sequence in C0. Okay. Here, xn equal to what? Here xn equal to, we write in this way, x1 whole to the power n, x2 whole to the power n, dot dot dot, xk whole to the power n, dot dot dot. Okay. This one is xn. Any problem? Not a problem at all. Now we also take this xn be Cauchy sequence. So what happened after that? Okay, we write now what happened. So here let epsilon greater than 0 be given. Okay, epsilon greater than 0 be given, and there exists n0 belongs to natural number such that n0 belongs to natural number such that this one x to the power m, x to the power n, that means m term difference n term with respect to norm infinity less than epsilon for all n m greater than equal to n0. Okay, I think not a problem at all. Okay, then we further proceed. Have a write about that supremum of k belongs to n, xk to the m, that means here suffix k, and obviously this one also is suffix n. Okay, k belongs to n. Then what happened? That means all elements. Okay, then what happened? Less than epsilon. Okay, for all n m, mn greater than equal to n0. This implies that what? Xk whole to the power m, xk whole to the power n less than epsilon for all mn greater than equal to n0, and k belongs to this natural number. We write it marked as star. Okay, not a problem at all. I think here some problem occur in creating video. I don't know why this problem occur, but this one, that means some problem occur here. Okay, now we're going to further discussion about that. Then this one be Cauchy gives this one. Now for this one, obviously one suffix or suffix, that means xm means some m term of sequence, and xkm means, that means k tuple, that means k tuple elements of m term of sequence. Okay, there's difference here, same thing, k tuple elements of nth term of sequence. Okay, nth term of sequence, and this one is k tuple elements. Okay, this difference less than epsilon for all mn greater than equal to n0 and k belongs to n. Then what we write here? Here for each k belongs to natural number, xk whole to the power n, each Cauchy sequence in k. Okay, is Cauchy sequence in K. Since K is complete, then what happened? Then xk whole to the power n, limit n tending to infinity, equal to xk. Okay, here belongs to this one k, since k is complete. Okay, so what happened? Then we define some x equal to similarly x1 x2 x3 dot dot dot. Okay, we now show that what x equal to xk, where k equal to 1 to infinity. Okay, in k, that means xk in k, not x is in k. Okay, so x, this one, we now show that this is in c0. Okay, this is in c0 means what? That means xk tends to 0 as k tends to infinity. Okay, now therefore mod of xk less than equal to mod of xk difference xk n0, okay, plus xk n0, this one equal to this one, and this less than equal to xk difference xk n0 plus xk n0. Okay, by triangle inequality for k belongs to this natural number. We write it now by triangle inequality. Okay, so we erase our portion and going to further discussion of that. Okay, what we write here, this one, simply we take m tending to infinity, then obviously what happens? If m tending to infinity here, then we shows that here xk n0. Okay, that means here we write not m, n tending to infinity. Okay, here that means if here we write they're not needed, the mk and anything is in 1. Okay, in 1, not this one, is this one we marked is 2. Okay, marked as double star. So here we marked is start, so taking m as start, then what happened? Then xk difference xk whole to the power n. Okay, because we know about that xk whole to the power m tends to xk as m tending to infinity. Okay, we know this one, so this one less than epsilon. Okay, then m tending to as here, as we write as m tending to infinity, or we write there exists n0 belongs to n such that what happened? such that here n0 also given here. Okay, that means for all n greater than equal to n0 is here, so n greater than obviously n0. Okay, that means in start this one is given. So what that means, for all m and n greater than equal to n0, so there exists n0 such that xk difference xkn less than epsilon for all n greater than equal to n0. Okay, this one is given. So what happened now? Now we write this one here xk difference xkn0 less than epsilon. Okay, so by here double star. Okay, we get what we get this one mod of xk less than equal to xk difference xkn0 plus xkn0. Okay, this one obviously what happened, less than epsilon plus mod of xkn0 for all n greater than equal to n0. Oh, this one is not needed here because we take particular n0. Now xk n0 tends to 0 since this one happened, or therefore this one happened since x n0 belongs to c0. Okay, so this one happened. So what happened, we erase that portion, below portion, then we write it here more xk less than epsilon. Here if we write this one this one tends to 0. Okay, if we write this one tends to 0, then that means then what happened, this one tends to 0 as n tends to infinity. Okay, as n0 tends to infinity, this one is 0, or as k tends to infinity, sorry, here as k tends to infinity this one happened. Okay, that means as k tends to infinity this one is 0. So what that means, what we write here as k tends to infinity, so what we write, that means xk whole to the power n0. Okay, n0 less than epsilon for all k greater than n0. Okay, here n0 belongs to natural number, we take, then this one happen. Okay, then what now we write this one is marked as, then this one marked as triple star. Okay, so from triple star we get mod of xk less than epsilon plus epsilon equal to 2 epsilon for all k here greater than some n0. Okay, n0 obviously there exists some natural number n0. Then what happened, then we also get this one, that means xk tends to 0 as k tends to infinity. Okay, xk tends to 0 as k tends to infinity. Then what happened, then obviously x belongs to c0. Okay, then what happened, now we erase that portion and going to further discussion of that. Okay, then we write it here in this way. Okay, here from this triple star, okay, supremum of x k n difference x k less than epsilon k belongs to n. Okay, for all n greater than equal to n0, and this implies taking supremum in both sides, then this one happened, then this implies xk whole to the power n difference xk infinity less than epsilon for all n greater than equal to n0. Okay, this implies what? X to the power n converges to x belongs to c0, so c0 be complete. And then what happened? Then c0 be a Banach space. Okay, to easily we prove this one. Okay, also to easily prove this, so today we stop here. Okay.